right, here we are, getting ready for, oh man, that's not gonna work. You can't have that on that line right there. How would I write right there? There we go, that'll work. Okay, we're doing the unit 6.2, lesson 6.2 video for those who were absent or those who just kind of need a refresher. This is what it looks like. Gosh, it's still in the line. Moving over, sorry for the, okay, there we go, that's much better. Oh. Whoa, okay. So this lesson is on rotation and translations, the two other forms of rigid motion transformations that we've not talked about yet. So one thing you want to keep in mind is that a rotation is a turn. The reflection, remember, was a flip. This is a turn. Okay. All right. A rotation, which we note with a capital R and a sub O, is a transformation that turns a figure around about a fixed point, and that fixed point is called the center of rotation. So if you look at our example right here, we've got this triangle right here, and it's rotating this direction around this fixed point right here, which is our center of rotation. Okay, so an object and its rotation have the same size and shape, which we've talked about. That's why it's a rigid motion transformation, because rigid motion transformations keep the size and the shape of the figure. So the only difference with a rotation is that the figures may be turned in opposite or different directions. All right, rotations can go one of two directions. The first one is counterclockwise, or obviously clockwise. And when we turn these, when it asks us to rotate a figure around something, it will do it in what's measured in degrees. So it will say like rotate 90 degrees, rotate 30 degrees, something like that. All right, so we have this triangle right here, ABC, that's been rotated around this point X some number of degrees. And so we can write that as triangle A prime, B prime, C prime. So this triangle is the image of triangle A, B, C. Now remember, this is a pre-image. The one before we do anything to it is the pre-image. This one is the image. Okay, so we've got triangle A prime, B prime, C prime is the image of triangle ABC under the rotation around point X. And an even simpler way to write that is that triangle A, B, C prime is equal to the rotation of triangle A, B, C. These are just quick little notations. So if you were to see something like this, you would know that this is a rotation of this triangle. Normally it was going to have some numbers down here that would tell you what it's rotating, how much. Okay. So there are some assumptions we need to make when we're working on a coordinate plane and we're talking about rotations. So when working in the coordinate plane, assume the center of rotation to be the origin unless otherwise stated. So remember the origin, let me move this up a little so you can kind of see this picture down here. The origin is where the y and the x-axis meet. It's right here. It's that point 0, 0. So unless it tells you otherwise, that's what we're rotating about. Also assume that a positive rotation, a positive angle of rotation, so for example, if it just tells you to rotate something 90 degrees, then you're going to do it counterclockwise. And I know that there is not enough room for that word on this dash. Sorry about that. Well, look, I could fit it. Scrunch it in there. And that a negative rotation would be clockwise. Unless told otherwise. So, things you don't want to forget. Clockwise rotation is like this. Or counter, sorry. See? Counterclockwise. Goes the opposite direction of a clock. And clockwise goes the same direction as the clock. So this is for a negative rotation. This is for a positive rotation. When working with rotations, you should be able to recognize angles of certain sizes. These are ones that you should know off the top of your head without really having to either think about it. Popular angles include 1/3 of a right angle, which is 30 degrees. That's about right here. Half of a right angle, which is 45 degrees. That is about right there. A right angle, which is 90 degrees. Then some other ones, 180 degrees, which is a straight line. 270 degrees, which is 3/4 of a turn. And 360 degrees, which is a complete full rotation right back to where you started. All right, so rotations in the coordinate plane. Here's some little rules to remember these by. Keep in mind that rotations on a coordinate grid are considered to be counterclockwise unless otherwise stated. So we have this rotation of 90 degrees. This is the same as a negative 270 degrees, because remember, negative means clockwise. Or if it just tells you 270 degrees clockwise, these are all equal to each other. That means if you have any of these, this would be the rule we're about to learn. This would be the rule you would use if you were given any of these three options to rotate. Okay, so a rotation of 90 degrees, we're gonna start with some point X, Y. For this example, I'm gonna use C, which is right here on our graph. So you can see that C starts out at the point 4, 5. And once it's been rotated, this point has gone from here to here. Rotation of 90 degrees. Once it's done that, oh, I should have used B. Oh well, once I've done that, you can see that the point C prime is negative 5, 4. So my question is what's happened to this X and Y? What have we done to it? Well, you can see that 4, 5, now 5, 4. So first of all, it's been flipped around. We've switched them around. And then this 5 used to be positive, but now it's negative. So we've taken the opposite of the Y. And if you look at all these, you can see the same thing. B was 1, 5, and now it's negative 5, 1. Okay, so we flipped them, and then we changed the sign. And again, that's for a rotation of 90 degrees. Remember, this is counterclockwise, or a negative 270 degrees, or if it tells you 270 degrees clockwise. Okay. Now let's move on to a rotation of 180. The rotation of 180 is the same no matter what it tells you. It could be a negative 180, or it could be 180 degrees clockwise. These will all be exactly the same because it's basically a straight line. And just for a future note, you might want to make a note of this. A rotation of 180 degrees is the same as a reflection plus a translation, which we will learn later, but just kind of keep that in the back of your head. Okay, so rotating 180 degrees, we start with some point, X, Y. For this example, I'm going to use point B. So you can see that point B starts off at the point 4, 1. And then B prime, after it's rotated 180 degrees, about the origin, B prime ends up being negative 4, negative 1. So how did we get from B to B prime? Well, all we did was change the signs of each coordinate. That's all we did. So that's the rule. Every time you just change the signs. Now remember, you guys, this negative right here doesn't mean that it's negative. It means that it takes the opposite. So if this one was originally negative, then it would become positive. It just takes the opposite sign. Okay. Last one for rotation, 270 degrees. A rotation of 270 degrees is the same as a negative 90 degree rotation or 90 degrees clockwise. All right, we're going to use point D for an example on this one. So we start with some point X, Y. So D starts off being 2, 1. Now, once it does a 270-degree turn, it ends up right here. So D prime's new point is 1, -2. So how did we get from 2, 1 to 1, -2? Well, we flipped them, and then we changed the sign of this back one. So we flip them, and then we change the sign of this one. Okay. All right, that's rotation. We'll do some practices here in just a second after we get through translation. On to translation. Okay, so reflections were flips, rotations were turns, translations are slides. We're just going to slide this image across the screen or across our coordinate plane. So translation, which we note with a capital T, moves an object a fixed distance. Ooh, didn't give myself room. In a given direction without changing its size or shape and without turning it or flipping it. Translations may be described by their movement, okay, such as 5 units to the right and 2 units down. It'll say translate this image 5 units right, 2 units down is how you'll see these. An object and its translation have the same size and shape because it is a rigid motion transformation, so it keeps its size and shape, and it'll face in the same direction. So here's an example. Here's triangle ABC. It's been slid or translated in this direction. We talk about how it's been moved along a vector, this vector A prime. So just like all the other ones, we can write this as triangle A prime, B prime, C prime is the image of triangle ABC under the translation along vector A prime. So we just slid it along that line. And an even simpler way to write it is triangle A prime, B prime, C prime is equal to the translation of triangle A, B, C. Okay. And then just as a side note, because we kind of introduced a new word here, a vector is a line segment with a known direction. So any of these are actually vectors. They're all line segments. Okay, talk about translations in a coordinate plane. Horizontal or vertical translations, this is one or the other. It's not both together. We'll talk about both together here in a little while. So what we want to notice is how each vertex is the singular, vertices is the plural. Notice how each vertex moves the same distance in the same direction. Now, if you guys did your crossword puzzle, you'll know that a vertex or vertice, vertex for the definition, a vertex is a meeting point of 2 lines that form an angle. Okay, so all of these points, does that show up? Yeah, all these points are vertices, or each one is a vertex. Okay, so a horizontal translation will change the x coordinate because it's moving along the x-axis. Remember, the x-axis is the one that's horizontal, left to right. In fact, I'd write that down here. I'm going to scoot this up so that you guys can see this a little better, all of this paper. Down here, make a little note. Horizontal goes left to right. Okay. And then a vertical translation will change the y coordinate because the vertical is up or down. So then right here, vertical, it's up, oops, down. All right. So really the easiest way to think about this is that we're just adding or subtracting whatever it tells us. So for example, if you look here, A, here's my original A. It's at the point negative 4, 4. And then we slid this 6 units to the right, and we ended up with this point right here, which is 2, 4. Now you can see that the y's stayed the same, and all that changed was the x's. So we started off with a negative 4, and we ended up with a positive 2. We got this by adding this 6 units to this one to get 2. Negative 4 plus 6 equals 2. Okay? So we're going to call whatever units it moves left or right A, because sometimes it will always be a different number. So we're going to just give it a variable A. So and you need to save room in here because we have a lot to write. A horizontal translation, A units, meaning some number of units, is going to look like this. We're going to start with our original point, but then whatever number of units we're moving, we're going to add to this coordinate right here. So it will be x plus a, and y will stay the same. So a vertical translation, an up and down one, we already said moves or changes our y coordinate. So we're going to call that b units. So we're going to translate vertically by b units, whether that's 7, 12, 562, whatever it is, that's what we're going to translate it by. So we start with the point x, y, and this time our x will stay the same, but we're going to add this number of units to our y. Okay? All right, so pay attention, a horizontal translation to the, a horizontal translation to the left will actually result in a negative number. So, like for example, if this had told us to go 6 units to the left, we would actually have a negative 6 that we would be adding here, or subtracting, I guess. A vertical translation down will also result in a negative number. So if it told me to go 4 units down, I would be subtracting rather than adding here, or adding a negative, however you want to think about it. Okay? All right. Now, I think that you guys might be missing some of these words. I can't remember. Some of them it seemed to cut off before. I don't know what happened, but if you are, just write them in. All right, last little part. Combined translations. When a translation slides an image both horizontal and vertical, both the x and y coordinates will be altered. So in the example below, you'll notice that each of the vertices, that's the corner points where they meet, of the shape A, B, C, D has moved 6 units to the left, which I just said would result in a negative, and 3 units up, which we would make a positive. Okay, so let's take, for example, B. So B starts here, and it ends up here. So we went 6 units back and 3 units up is how we got there. So what we did was, for our x term, our x is a 1 right here. So we did x1 minus 6 gives us a negative 5. And then my y term is also a 1. So I did 1 plus 3 is 4. And that's how I got the new point, negative 5, 4. Now it's also super easy to just think about going 6 units back and 3 units up and making a dot. And if that's super easy for you, then please do it that way, okay? But the little trick that you want to know is for a vertical translation, B units, I should have put horizontal first, and a horizontal translation, A units, it'll look like this. You start with your point, x, y. Okay, and then we're going to add A to this one and B to this one. So it's going to look like x plus A, y plus B, and then we're done. All right, so some things to remember. A vertical translation will add or subtract your y coordinate, and a horizontal translation will add or subtract your x coordinate. And again, just remember that vertical is up or down, and horizontal is right or left. Because it's not going to tell you do a vertical translation of 3. What it's going to tell you is translate this thing 3 units up or 3 units down. So you want to know which one goes with which. And if you have a hard time remembering them, hopefully that will help. Okay, so that is all the notes for this unit. Let's quickly go over this thing really quick. I just want to kind of help you out with this one before you get started on it. So this one is a rotation of 90 degrees. If you look back into your notes, this is the one that we said we start with X, Y, we flip them, and then we change the sign of the first one. Okay, this one is a rotation of 270 degrees clockwise. So if you look back at your notes from the rotation, you will see right here that we said a 90 rotation is the same as a 270 clockwise. So that means that this one is exactly like this one. It's doing the same thing. So this one you're going to start with your point and you're going to switch them and then change the sign of the first one. All right, translations right here. So this says 6 units left, 3 units up. Remember I said left is a negative, so this one you're going to take your X and you're going to subtract 6. And because it's 3 units up, you're going to take your Y and add 3. Or what you're going to do is just count backwards 6. 1, 2, 3, 4, 5, 6, and then up 3. 1, 2, 3. Right here is the new U point. This one, 2 units right, 3 units down. Right is positive, so you're going to take your X coordinates and add 2. This one is down, so you're going to take your Y coordinates and subtract 3. Or you're going to go right 2, 1, 2, down 3, 1, 2, 3. Okay? So that's some help on those. These two I want you to try and do on your own without any help whatsoever, and make sure you get that turned in as soon as possible. You only have one day to make it up, so make sure you get it turned in right away. Thanks, guys.